Hi apes. Today we're going to be taking a look at Unit 7 Part 1, which focuses on air pollution. Now to start off with, this is a very cool picture of our atmosphere. You can see here this is our lowest level of the atmosphere, troposphere, and one key thing that you can see that you know it's that is that you have the clouds reaching their upper limit here. So troposphere is where the weather is located, and this is also where our air pollution is going to be focused on today. Here's the stratosphere. The next one up is the mesosphere, and then here is our thermosphere. So we'll be staying entirely in the troposphere today. Now just to start off with, I do want to go over our different types of air pollution. So one thing to note is that you do have both natural and anthropogenic. So here's just a good time to remind you guys that anthropogenic, what this means, is man-made sources. So we do have both. Some examples of natural sources of pollution would be sulfur from volcanoes. Also things like dust and pollen might be natural sources of air pollution. And for our anthropogenic or our man-made ones, most of those are going to be coming from the burning of fossil fuels. And another big one is construction. So that can be a source of anthropogenic dust particles or other components from construction sites. So there are both different types of air pollution. Now, some other vocabulary that might fit along with this are point sources. So I like to think of point sources as something you literally can point to. So one big source of this is like a factory smokestack. So the thing about point sources of pollution is that you can measure it, and you hopefully can contain it or treat it because you know exactly where it's coming out of. Now, a little bit more difficult are area sources or non-point. So this might be from, say, an agricultural area or from a collective urban area. So you don't have one key source. Now, the one thing that's very unique about air pollution is you can have mobile sources, and those are our sources of pollution that move around, like cars. Now, the air pollution problems that we might have, one is that it greatly reduces visibility. This is related to smog and that haze that might form when you have a lot of air pollution lingering in the air. Another thing is some types of air pollution can directly harm vegetation. It can burn their tissues. It can make it so that they prevent photosynthesis. And if you prevent the photosynthesis, then what happens is that you are damaging an ecosystem at its primary producer level, and that can cause a series of problems up the food chain. Now, one of the key things that we focus on with air pollution is that it can be very harmful to both human and animal health. And where it targets mostly is either the respiratory irritants or eye irritants, because that's where the air will encounter our bodies first. So oftentimes we say it irritates the respiratory system or the eyes. Now, some very specific human health problems that might be able to come from this are asthma. It can aggravate asthma. It can cause cancer in some cases. Radon is linked to a very specific type of cancer for lung cancer. Now, a lot of times for the AP test, you will have to refer to a specific type of cancer because most air pollution is not going to cause, say, liver cancer or bone cancer. So most of the times you do have to say the very specific type of cancer, in this case, lung cancer. It can aggravate bronchitis, and in some cases it can cause premature death because it impacts how we breathe. This is just a good visualization of different sources and removal techniques for air pollution, as well as how it moves through our atmosphere. So some natural sources are lightning can convert some pollutants in the atmosphere to harmful ones. We have forest fires that could be either natural or anthropogenic. We have agricultural techniques that can become airborne and cause pollution. Definitely our industry, this would be primarily our fossil fuels. Transportation, again, is our fossil fuel, so those are our mobile sources of air pollution. How it moves through our atmosphere is primarily through wind. So this is key with air pollution because pollutants that are created, say, here, might have an impact elsewhere. And you might have noticed this late summer and fall with the forest fires out west. Even all the way out here, we saw the impacts of some of those forest fires because they were picked up by the winds. Now we're going to talk about how the sun might change some of our air pollutants. So there are some pollutants that are only created in the presence of light. We call that photochemistry or photochemical reactions. We have reactions that go on in our clouds to form acid rain. And then how it comes out of our atmosphere is mostly through deposition. So through rain, or it can also be dry deposition. And then the black are the effects. So it impacts our visibility with our haze. Sometimes acid rain can damage our cultural resources. It can damage forest productivity by preventing photosynthesis. It can get into our waterways and affect our drinking water, and sometimes it can lower the pH with acid rain. Also can get into our groundwater and our soils, and that can tie into human health. So our air pollution is actually key everywhere around us, and it has lots of different components to it in our ecosystem. So our major components for air pollution, we can classify as either primary or secondary pollutants. Now a primary pollutant is released as is from a source. And so by this, I mean that nitrogen oxides, sulfur oxides, particulate matter, these are all released in that form from their pollutant source, in this case mostly fossil fuels. Now a secondary reactant is formed by reactions. And so we'll talk about three main types. We'll talk about ozone, and we'll talk about sulfuric acid and nitric acid that forms our acid rain. So those have to form by reactions. You don't just release acid rain into our atmosphere, it forms in the clouds. And we don't release ozone, we release precursors to ozone that in the presence of sunlight will react to form ozone. So that's the difference between our primary and our secondary reactants. Or pollutants, excuse me. Now, we do have 6 primary criteria air pollutants that are governed by the NAAQS. And the NAAQS stands for our National Ambient, which means outside, Air Quality Standards. So these fall underneath the Clean Air Act. And so that we often abbreviate as CAA. So the Clean Air Act, what this does is it sets minimum requirements for human health. And so really probably a little bit better way to say that is it sets maximum levels of safe qualities or quantities of these pollutants in our air. So it will set limits, and if you go over that limit, you are in violation of the NAAQS. So the one that we most often are in violation of the NAAQS in our area is ozone. So we'll talk about how ozone forms in a little bit. But these are the major air pollutants, and the key thing is these all have direct human health problems. So NOx typically come from fossil fuels, so from the burning of coal, oil, and natural gas. Same with sulfur dioxide. Now both of these will act as a respiratory irritant that can affect directly human health, but alternatively also they will lead to the creation of acid rain. Now carbon monoxide comes from fossil fuels, and the key thing about carbon monoxide is it outcompetes hemoglobin for oxygen. So it deprives your cells of oxygen and can lead to death. PM stands for particulate matter, and this is released from fossil fuels or also some construction products. So particulate matter is a respiratory irritant, and so that's why we keep an eye on our levels of particulate matter. Now we do measure the size, so particulate matter is literally particles in our atmosphere, and so we can measure that by 10 micrometers or 2.5 micrometers. And the 2.5 micrometer ones are even more dangerous because you can inhale those deeply into your lungs, and that can lead to respiratory problems. Ozone is a respiratory irritant, and like I said, in our area, this is mostly why we might be in violation of the NAAQS. And so ozone is a severe respiratory irritant and an eye irritant, and this is when we get into our code red or code orange days. It's because our ozone layers are getting too high. And then finally, lead. Lead was most often found in gasoline, and this is actually a huge success story of our Clean Air Act, that when they shifted from leaded gasoline to unleaded gasoline, we saw incredible drop in our lead. And so this was a big success story of our NAAQS. And lead, the reason why we had to make that change is lead is a neurotoxin. Now, there are other types of air pollutants that you might hear about, and those are CO2. We'll talk about that. That is not technically an air pollutant governed by the NAAQS because there isn't direct human health harm from it. But CO2, as we're going to see, is an incredible greenhouse gas, and one that we'll talk about a lot in the future as being tied to our climate change. Now, others are VOCs. These are volatile organic compounds. Now, a lot of times you might get this from gasoline. And a volatile organic compound, one of the key things about these is that it has a scent. They are airborne, that's the volatile part, come from organic or living things, and compounds. So this is a big subset of pollutants, but VOCs might lead to our production of smog, and that's why we need to introduce it. Now, urban air pollution is going to have its own set of problems. We're actually going to come back to some of these in Unit 7, Part 2. But just to introduce our topic of urban air pollution, is that you might have in urban areas what we refer to as an urban dust dome or a heat island effect. So because we have so many constructions or so many industries and so many cars in urban areas, it tends to create a lot of air pollution. And with that urban dust dome, sometimes because of atmospheric changes, you might trap some of those air pollutants over a city. Now, we have already talked about our urban heat island effect, that where urban areas are slightly warmer, because you have a lot more industry and a lot more cars and you have a lot more pavement. So these kind of exacerbate that problem, and that's why you see a lot more urban areas with warmer temperatures and more pollution. So in Unit 7, Part 2, what we're going to take a look at is how we trap those pollutants and how those pollutants actually form when we discuss smog, and then talk about how it's trapped with our atmospheric inversion.